Think about this. If you wanted to power up an entire city for a day, you need a train loaded with coal stretching over 10 kilometers long. Now, what if I told you that we can replace all of that with one bucket of fuel? No pollution, no carbon emissions, no endless supply chains. And here's the craziest part. This energy source is burning for billions of years right above our heads, and we haven't figured it how to use it until now. Earlier I talked about something that is doing it for billions of years right above our heads. And that, ladies and gentlemen, I am talking about our hottest, dearest friend, the sun. Now, what if I told you that we are creating a mini sun right here on the earth? Sounds interesting, right? So what is the sun's secret? So the sun shines because of nuclear fusion, where hydrogen atoms smash together under extreme heat and pressure to form helium, releasing massive amounts of energy. This particular reaction has been powering our solar system for 4.6 billion years. Now, how to replicate that particular scenario right here on the earth? Now, what I'm stating is how to create a mini sun on the earth. To recreate this, we need hydrogen atoms and extreme heat. When I say extreme heat, it is 100 million degrees Celsius, which is 7 times hotter than the sun's core. For this, we use special types of hydrogen. Those are deuterium, which can be found in seawater. 1 liter of seawater contains enough deuterium to produce as much energy as 300 liters of gasoline. On the other hand, we need tritium, which is made from lithium, the same material that we use in our phone batteries. When deuterium and tritium are heated to extreme pressure and temperature, they undergo nuclear fusion and become plasma. In simple words, they move so fast and they smash into each other and form a helium nucleus and a free neutron. The total mass of helium and the new neutron is slightly lesser than the original deuterium and tritium combined. This lost mass gets converted into huge amount of energy according to the Einstein's famous equation, E is equal to delta mc square. Here delta m is equal to the lost mass and c is equal to speed of the light. Since c is a huge number, even a tiny loss of mass results in an enormous energy release. Now we have created the energy, but if you remember, we are creating a mini sun on the earth, which is 7 times hotter than the sun's core. We have to store it somewhere or handle it, right? It is simply like controlling a star. Since plasma is hotter than any material on the earth, we can't keep it or we can't let anything touch it because it will melt it right away. So we use powerful magnetic fields to create an invisible case inside a reactor called a tokamak, which looks like a donut holding the plasma in the correct place. Let's talk about this reactor soon, but let's see how this particular energy can be used in different parts of the industries. And the very first one is electricity generation with no carbon emissions and no long-lived nuclear waste. It can be used as fuel for hydrogen-powered cars, airplanes, and vehicles. It can be used in space propulsion. A fusion-powered spaceship could cut travel time to Mars from 7 months to just 2 months.
Oh my God! Wow!
It can be used in desalination, where we convert the seawater into drinkable water. And there are lots of ways that we can use this power, isn't it? But wait, this is sounding like a science fiction movie. Who is really working on it to making it a reality? Well, a lot of people. ITER in France, the world's biggest fusion experiment, building a massive tokamak reactor, which we talked about earlier, to sustain plasma at over 150 million degrees Celsius. And National Ignition Facility in USA, they hit a huge milestone in 2022 by getting more energy out of a fusion reaction than they put in. JET in UK holds the record for the highest fusion energy output, proving large-scale fusion is possible. Private companies and startups like Helion Energy and General Fusion are racing to build the first commercial fusion power plants. So yeah, fusion is no longer just a theory, it's happening. So now let's talk about how powerful this nuclear fusion is. So let's say, how many airplanes can it power up? A Boeing 737, one of the most common planes, needs about 3,000 liters of jet fuel to fly from New York to Los Angeles. It's a 5-hour flight, but with fusion, we could get the same amount of energy with just 2 liters of seawater. That means a single bathtub of seawater, that is 200 liters, can power 100 flights across the US. Now, 1 liter of seawater is equal to 300 megawatts hour of energy. A Tesla Model S needs a 100 kilowatt hour for a full charge. That means 1 liter of seawater can charge 3000 Tesla cars. With a single bathtub, that is 200 liters of seawater, you could charge 600,000 electric cars, enough to power every car in a city the size of Los Angeles for weeks. The average home uses 30 kilowatts hours of energy per day. That means 1 liter of seawater could power a house for 10,000 days. That is 27 years of electricity from a single liter of seawater. So a bathtub of seawater could power up a small sized city for an year. Now that means a single water bottle could replace a half a ton of coal. Wow.
Hey, come on, baby! Come on! Yes! Come on! Yes!
But you might ask me, is nuclear fission so costly or is it expensive? Right now, yes. But in the long run, it might be the cheapest energy source ever. So the ITER project that we have talked about in France, the world's most expensive power plant right now, which has $25+ billion right now, which is crazy expensive. But remember, first time tech is always expensive. The first airplanes, the first computers, even solar panels were very costly at the initial stage, right? But as we scaled up, the cost dropped massively. And the cost of fossil fuel that we have talked about, 2 hydrogen atoms, that is deuterium, which can be found in seawater, and there's enough to last millions of years. Tritium, the other fuel, is rarer, but we can make it inside the reactor using lithium, which is already used in EV batteries. So compared to coal, oil or uranium, fossil fuel is practically free. So once the tech is ready, we will have unlimited clean energy. We are definitely blessed to have those kind of amazing scientists working their ass off for making a better and bright future for all of us.
Thanks a lot. Thank you.
So what do you think about nuclear fission? Do you like it? Please let me know in the comments. And I hope this nuclear fission comes into the picture into our world as soon as possible, so that we can remove all these carbon emissions, nuclear waste, and all the things that are hazard to the environment and the nature. And if you haven't seen our latest video on the quantum computers, please check out this video. I'll put the video link in the description as well. And if you are interested in knowing about more groundbreaking science technologies that are coming in near future, please subscribe to the channel. And if you like the video and if you found something valuable in this video, please consider liking and subscribing and sharing it to your friends. Thank you very much. See you in the next video. Bye bye.